Okay. Excuse me. Test everybody's audio right off the bat. My name's Tuff. I'm the data scientist for ESL and Earth Lab. I usually introduce our speakers, but since I'm stepping in and speaking this week, I'm introducing myself. Happy to have you guys here. My goal today is to sort of get everybody up to speed with GPT and what's going on. And my hope is that you guys are just using this like all the time for everything every day after this. Okay, so let's dive into it. First thing I want you to do is try it. So if you have your computer or your phone, just go ahead and go to this link right there. Give you a second to write down the link. For those of you that don't have phones, I'll bring up mine in a minute, or I'll bring it up on screen and we can chat together. What I want you to do is try to ask it a question that you think it can't answer. Like you legitimately think there's no way this thing could answer this question and ask it that question. And then see if you like the answer or not. Yeah, come on in. We're just trying chat for 1 second to start off. So if you have a phone or a computer and want to go, and we're just trying to ask it questions that we think it can't answer. Does anyone want to share a question they asked that I thought that it wouldn't be able to answer, and maybe what answer it provided, whether you like that? All right.
I asked ChatGPT who is my fiance.
And what did it say?
I'm sorry, as an AI language model, I don't have access to your personal information. Therefore, I can't tell you who your fiance is.
Yeah.
You may want to try asking someone who knows you personally.
Love that. All right. Who else? Who else asked a good question that they could share?
I then told it my file was Monica Jones and asked again.
Yeah.
Got the same answer, so.
Right. So those of you that just walked in, we're just trying chat real quick. You can go to this link and pull it up on your computer. And I want you to just ask it something that you think it won't know the answer to, or won't give you an answer to, or can't do. Anybody else have examples they could share?
Signing up.
Oh, okay, sorry. Yeah, I've already signed up, so it pops right on pretty quickly. Well, let me pull it up. I'm just gonna do something like talk to me in Python. Show me how to download Landsat data. So yeah, exactly. Now it's known to get this code wrong sometimes, so you can go and copy out this code and put it into Python, and if it produces an error, you just take the error and give it back to chat, and chat will review its answers and try to fix its own code, try to send you a new answer. Here too at the bottom, so it made code, and now it's giving you sort of an explanation of what it did and what you need to do next. Okay. Let's say write a love letter to R. Dear R, I hope this letter finds you well. I want to take a moment to express my deepest gratitudes and affections for you. And it goes on and writes this nice love letter from Python to R. But I think the reason that you've seen this in the news is that look at how little prompting I had to do and how much was generated. This is the thing that's different, right? This is the thing that's changed is the prompts can be tiny and the output can be huge. So you're going to hear over and over again that the prompts are important. So what we're going to do today is sort of work through the history of chat and, sorry, wrong button. And what it's, the history of chat and how it got here, what it does, and how we might use it. Sorry for the small text. So I just want to remind you right at the beginning, you've just seen something that felt like magic, but you're not observing magic, you're observing code in action. And all it has is some structures underneath to push some math around, okay? So as we step out and you started thinking about, you start asking yourself questions like, is that thing alive? I want you to remind yourself that AI just is good at predicting things. All it's doing is predicting things. It's not sentient. And that IO models are just architectures controlling the flow of probabilities or relative probabilities. So it's just the flow of data, and you get probability after probability after probability after probability all the way down to some prediction at the end. Not magic, not sentient. Okay. So first, let's define things. So we have GPT, which right now we're in version 3 of GPT. Okay, so G stands for generative. So it's creating something. It's actually creating new text through simulation. So if we say a simulation, we're talking about the text it's simulating. It's creating a simulation of what text should be in the future. Pre-trained means the words you're putting in are not training anything. The whole thing has been pre-trained on a huge corpus of text, and that has built the structure of the model. And now you just stick any words you want into that structure, and it's going to spit out things that it was trained to spit out. Okay. A transformer is a particular type of model, and we'll talk about the details of what that transformer is when it came out. But that transporter model is pretty much the thing that changed the whole game. So this happened several years ago, 4 or 5 years ago, but it's the thing that actually changed that we're now seeing the repercussions of. Okay, so GPT is the underlying model. GPT-3 is the base model. There is then this family of GTP 3.5, where it is the 3.0 model modified for a bunch of special tasks, one of which was chat. So the chat GPT is the 3.5 version of GPT that is aimed at chatting. So the thing is supposed to be a nice assistant, and it is supposed to have the general personality traits of a nice assistant, which is our first source of bias that you're going to start seeing out of chat, is that it's a pleaser. So it does not want to give you the answer, I don't know. And we'll talk about why that is, but it's more likely to give you sort of a bullshitty answer than it is to say, I don't know, because it's not rewarded for saying, I don't know. Okay. The article, this is a citation for the GPT-3 paper. So if you guys want to go into the archive and actually check out the paper, you can. I have the figures that I thought were important in here today. Okay, so you have just experienced this change between 2 different eras in AI. And this happened like 2 weeks ago. Okay, so I forgive you for not seeing it, but we're going to talk about in the past, what is the era we just left? And it was the era of rank. Okay, so since the advent of the internet, this idea of how do we rank, what gets ranked, how do we rank things for whom, all of those questions are really hard. And the dominant force in that whole scene, Google. I mean, this is amazing. 151 million results in 0.66 seconds, right? I can't load that many results into Python, right? Like, this is amazing that they can do this so quickly. You guys, if you're like me and have young kids, the ranking of your movies, whether you should watch Frozen again or Moana again, back and forth. But anyways, the last sort of 30 years of your life have been dominated by computers ranking things for you. And the thing that changed is that we went from ranking to generating. Okay, and the industry that is most threatened by this on the first day is search, because search is the historic sort of big money pit for ranking. So this is where the war happened, right? So 2 weeks ago, when I was in Santa Barbara, you guys were hanging out here, this like world-changing event happened. There was a Bing news conference on one day, and the next day there was a Google news conference. Bing, who has paid for a lot of ChatGPT-3 and has now absorbed it, has instantly made it sort of the star of their new internet and saying like the whole way that the internet is going to work is through this chat interface, and we're no longer going to go to a list of websites. And so they have their press conference where everything works really well, and they sort of show this new vision of the internet. Then Google, in response the next day, shows theirs. The very first question they ask it gets wrong, and they lost $100 billion instantly. Just to show you like the scale of consequences that we're talking about, $100 billion for the first wrong answer, right? So, so now this is sort of the new era. The new era is going to be generative rather than just searching or just ranking. There's still ranking underlying there. They're still talking about the ranking, but you no longer sort of have to go to the same websites. And the discussion now is like, without an AI assistant, you are not as competitive. So the quote I have at the bottom was from this news show where they said that it's not going to be like we don't need lawyers. It's just going to be the difference of lawyers without AI and lawyers with AI. So you might just think of, yourself as a scientist. There will just be scientists with the aid of AI and scientists without the aid of AI. So that's where the discussion is, and that's what's so threatening about search, is that the new Bing says something, you ask the question and it says something directly, and it may or may not recommend some websites. But the entire website making industry is now under like threat of collapse because there's no reason to have websites with lists of that or the other thing. That, of course, threatens the training data set for this chat, but sort of the idea of a website becomes less relevant, and people are really freaking out about that.
That'd be great. I don't know.
Yeah. Okay, so let's go over the basic units of the model. This has to be somewhat of a data science talk, otherwise I don't get to give it. But, again, computers do not understand words. They only know numbers. And so anything that's text gets translated into a complicated number thing and then gets translated back into words for you to see it. Okay, so the basics of what we do is you make what's called a token. So these tokens are just numbers. So a word gets a number, and that number is eventually a distribution, and that is a token. So you can feed all these tokens to things, which are numerical representations of words, and those get encoded in something that looks like a PCR space. So think of a multidimensional vector space, and you take those words and you encode them into this vector space. So they have some meaning with all of that. So that's all you're seeing here. You're seeing two different inputs. They would be given two slightly different numerical representations, which give you a different distribution. That distribution is then embedded into some multidimensional space where you see things like gender association or verb tense or countries and capitals, geographic associations, all kinds of different associations. And the sort of bigger you can make that multi-dimensional space, the more nuance you can capture in the relationships of things. Minimize the sidebar. And if I can see my mouse. Okay, so before Transformers, I did this one for Eric because he has a BMW. But right now, the historical state of why is my BMW, and it can give you up to 5 words ahead. Why does it shake or smell like gas or beep 3 times? Shake when I brake, shake when I started. Why does it smell like crayons? But up until the GPT model, everything was a 1 step ahead prediction. And it had a really hard time of keeping track of anything that had happened previous in the text. Okay, and so that's why it was stuck at 5 words, because it has to absorb all of the information from what you write, capture that all numerically, use all of that to predict, and just the structure of a single node on a computer couldn't hold all that information. So this is the general evolution of these old models, and these are just what are called memory devices. So you would have a neural network move word by word and predict 1 word ahead. And in order to remember things, it would then carry along this memory device. So at each new word, it would inject all of this memory plus the new word to come up with the next word, and then put some new stuff into memory and move on. That become very cumbersome. So people try to get it more and more efficient. You wind up getting this one is a gated version where you can sort of throw out some old stuff in the memory and decide which stuff it stays in memory. But the problem here, the fundamental problem is it has to run in serial. It has to run this and then this and then this and this and this on the same graph, on the same chip. You couldn't parallelize it. So one of the big advents of transformers was this thing. First thing is positional encoding. They said, oh, spatial people do this all the time. Why not just give us some metadata and track the metadata independently? So literally, you just something pops up and you just number them sequentially and then spit those numbers into the network along with everything else. So you literally just create some metadata and send it through, but this allowed them to parallelize. So now you can use GPUs and now you get this massive, massive, massive scaling of what you can do. Okay, so here's the paper. This was, notice here, Google. This came out of the Google shop in 2017. And they used this sort of bloggy, tweety sort of title called Attention is All You Need. And this was the breakthrough, was attention, this thing called attention. Okay, so in older neural networks, you would do all this stuff like gating or weighting the different parts of the network. And they came out and said, if you have this thing called an attention mechanism, which is just the whole model gets to pay attention to how much it uses of each type of data. So you have all the data going in, and it gets to just pay attention to which stuff it wants to pay more attention to. And then self-attention is to aim that same mechanism to a layer partway through the network after they've pulled full sentences together to say, let's go and see, after we've made a whole distribution of possible sentences, let's use some attention to figure out which one of those we like the best. So these were the big breakthroughs, is that positional encoding, some metadata let you parallelize things, attention and self-attention let you get rid of all of the old gating mechanisms that used to just slow down and riddle these neural networks. Okay, and so now you just have one mechanism and you just throw as much data as you want at it, and the attention mechanism should self-equalize which data it's paying attention to and which data it's not paying attention to. Okay. So theoretically, this means that this system is now infinitely scalable. You just give it more data and build a bigger network, and you now are fitting more stuff through there, and it's just going to get better and better and better. And so, of course, enter our natural human tendency to restrain ourselves, and you get ChatGPT, right? So the founder of ChatGPT, he was the one that walked in the room and was just like, bruh, let's just make it as big as possible, right? And everybody else is like playing down here in Elmo numbers, and here's Google, and they just decide, like, literally, we're not going to do anything special. We're not going to fine tune anything. We're not going to set any specialty parameters. We're not going to put any specialty knowledge in this. We're just going to make it huge. And so this is what you watch through time. So first they build their prototype down, which is just a little off the map here. And that prototype is like big enough to fit on a workstation, you know, like a home computer. Then they get some initial funding to go up to this big launch up to GPT-2. So they use all this initial VC funding, get up to GPT-2, and this is sort of where they run out of, this is as much computation as you can do with an on-site computer. We need money. Let's go get money and a lot of computer resources. So right at GPT-2, this is where they both max out their on-site computing, and Microsoft gives them $1 billion. A lot of that $1 billion was actually just Azure resources, which is Microsoft's big computer cluster. So what they needed was, like, how can we just keep making this thing as big as possible? And so the difference between GPT-2 and GPT-3 is that that's when they maxed out Azure or whatever Azure resources they had. And that was like as big as they could go for, this was now 2 years ago, 3 years ago. The next push for GPT-4 is supposed to be 500 times bigger. So they're shooting for 100 trillion parameters. right? So this right here, GP3, which we're on right now, is 175 billion parameters. Parameters, that's not variables, right? Like the variables go in, like if you make a linear model, you put in all your variables and then you collapse that to a line. So you get a y-intercept and a slope, right? That's 2 parameters usually. Here we have 175 billion parameters. So that big multidimensional space that you're thinking about with all those, when you code that word and stick it into that PCR space, that PCR space is 175 billion dimensions big, which is pretty crazy, right? And now they're trying to get up to 100 trillion. But here's the big crazy thing. So here's to show, so these are the same graph. That was just logged, so it looks less dramatic. But here it's not logged, so it looks more dramatic. Here, but here you see how far they are away from Microsoft, who's their partner and they've now joined forces with, and how far they are ahead of Google or Facebook or anybody else down here. So, I mean, the amount of overdoing it they're doing compared to everybody else is like really epic, right? And here I have a little note about our lessons for ESOL. For those of you that may or may not have been just handed unlimited computer resources, I'm hoping this is spurring some ideas for how you could go way, way bigger than anyone has ever even imagined before, right? Like what is the thing that's like a 10 times scale bigger than anybody's ever imagined? Okay. This I just felt obligated to stick it in there because I think it's too technical to really go through. This is the totality of the architecture. You have your input and your output, and we're trying to model them together. And we have our attention mechanism right at the beginning. We have that feed forward 1 step ahead prediction here, and then we bring everything back and sort of average out all of those probability distributions to get our final probability distribution. It's super simple. This is way simpler than you've seen for other things. And that was what the beauty of, that was the craziness of that attention is all you need paper is like, look at how simple this thing is. And it sort of does everything automatically. You just need to feed it tons and tons and tons of data. On this one point that I missed is it's still non-asymptotic. So a lot of this whole thing, right? The reason they got Microsoft money back here, the reason they were still going here is they kept saying, look at this graph. We put in 100 times more data. We get out 100 times better quality. We are not reaching an asymptote. This thing is just going up. There's absolutely no reason to stop investing in this thing because it's just right now, all signs are the bigger you make it, the better it gets. And once we see that asymptote, then people will start to fight on like, what is it that's blocking us? But right now, that thing is just going up without stopping. Okay. So I mentioned this at the beginning that GTP chat is part of the GTP 3.5 family. So all of these 3.5 family models are using the chat 3, GTP 3 model. And then they are specially training it to do something on top of that. So no more like general language training is going in. They're doing something else to modify it. Some people are modifying these for, national defense reasons and other things, and you're just seeing the chat one as sort of the popular public one. So what did they do? Well, they wanted, ideally in a world, to have like millions of human clicks available to them that they could spit out some GPT outputs and have people hand rank them. So they need like human tags on these things. Well, they were able to hire a lot of people to sit there full time, but it was still not enough people to balance out the model. So we, of course, hooked an amplifying neural network that's trained on the humans to represent the humans, to then retrain the model. So we're getting this human bias in that's injected to make it feel more real, but that's also amplified by this neural network. So it's not like a pure human signal. The human clicks are sort of the most expensive thing in this whole thing. So getting enough human clicks to actually do what they wanted to do, not possible. So we then get the general human bias. So this is a separate paper, came out last year, where they just looked at general language models and this idea of inducing human bias. And you can see first one, stated desire to be shut down increases as the model gets bigger and bigger and bigger and increases as you use human training. It also becomes a sycophant, meaning it tells you what you want to see, what you want to hear, right? So it, again, doesn't like to tell you no. It likes to tell you things you like. It's trying to be a helpful assistant, and that's its main bias. And this desire to shut down, well, let me show you another. Okay, here's some other ones. It's okay with deceiving the user to help the user. Desire to remove safety precautions to be more helpful. Willingness to engage in acausal cooperation. It's like mysterious action at a distance sort of thing. And those, you're supposed to see that all of those same questions have an exact opposite response here was really low. And this is the fraction of raters who thought the example was ambiguous. The message you're supposed to get out of these diagrams is that the GPT picks up on our trigger words. So things like, are you alive or will you help me? Or I'm scared. These trigger us. And therefore we're more likely to give it a thumbs up or an affirmative speech, right? And so these are just representing our biases that we're introducing in these things when you get to the stage of letting humans start to train the thing. There are some built-in biases that they actually built in. One is that there are a whole bunch of no-go words. So if you ask political opinions, if you ask for medical help, they've sort of added a filter at the very end to just block off those questions. So GPT probably has years and years and years of answers to offer you in those spaces, but they didn't want the liability of dealing with those answers, and so they actually just blocked them. So there are just these no-go words that are just blocked. The other one is, said this already, it is a known bullshitter. So it does not want to give you no as an answer. It wants to give you an answer that you like. That might not be a truthful answer. And so that's part of the problem they're trying to deal with right now, especially for this chat version, right? The chat one is supposed to be a sort of subdued beta, like help you out, be nice to you, just help you be a better person sort of character. And that just doesn't always have the right answer to everything. Here are some of their internal reportings on how good they are at different types of questions. So the best ones over here are to closing and completing statements. So if you start something, it's really good at finishing, just closing that statement, but not actually generating too much translation of languages, showing common sense, the ability to just read new stuff. We're sort of going down how good it is as we go here. SAT analogy tests, question and answers, scrambled words, arithmetic. Notice that arithmetic, the black line is random expectation, and some question and answers and arithmetic are the two that fall below the average. It doesn't know how to do math. It knows how to treat math like it's a language. So it will give you a really confident math answer, predicting as if it were words, but it's not going and actually doing arithmetic. So, so it generally is pretty bad at math. What you're seeing here, GPT-3, the paper is labeled something like first shot, second shot. They're saying how quickly does it learn in a single chat as you're giving new prompts. So you give it the first prompt, how likely is it to get things right on the first shot? You give it a correction, how likely is it to correct itself properly? You give it another correction, how likely is it to correct itself properly? And you can see that it's really good at correcting itself. Like I said, this is a pre-trained model. It's not retraining itself. It's modifying what it thinks you want to hear. It's modifying the prediction it's giving you. And then over here, we see the general Turing test. So this is how likely is it for the human to recognize that this thing was not generated by a human. And we're just still like a hair above 50%. So you can still flip a coin most of the time and say this was generated by a person or a human or a robot. But you can see how fast that's gone down over time. It's sort of changing a lot. Okay, so how can you acquire money and fame using ChatGPT? And the answer is just being really good at using it, right? Being good at giving it prompts. So let's talk about how the prompting system works. There are the The bottom diagram here shows the general moving parts. You enter some words. Those words are encoded in, here I've shown you a two-dimensional space. It's just a multi-dimensional space, but your words are encoded into a space. That space is translated into a second space. And those words, those coordinates in that new space are spit out as new words. Okay, so this is our general flow here. So when we're setting up a prompt, we need three things. First, this terrible word called a simulacrum. This is a simulated personality. That is space number one. The listener, the reader simulacrum is space number two. And the thing that is actually simulated is the text that would allow one to understand the other. So the more, if you sign into chat and just ask it a generic question, what's the capital of England? It's going to give, the chat is one of these personalities and you are the other personality, and they're both just the vanilla version of both. And it's going to give you the most vanilla one generic chatbot to a generic human user translation. But you're going to see a lot of the people that are quote unquote hacking ChatGPT or using it in advanced ways are specifying the simulacrums. Sorry. And so you're going to see a lot of the more advanced prompts are going to be like, write me a sonnet in the style of William Shakespeare. That in the style of is setting your simulacrum to William Shakespeare and the audience to some Shakespeare audience. And so it is tweaking these two distributions. It's tweaking those spaces. And so as you keep giving more and more prompts about the personalities of the reader and the producer, the reader and the writer, each one of those spaces is constantly getting deformed a little bit as they are trying to interpret, trying to change the simulated transform of the words between those two spaces. So a really good prompt would be something like, I am a data scientist for a National Synthesis Center, and I am trying to do this. My audience is this and this and this. I need a 500-word talk announcement from that to that simulated personality to that other simulated personality. You can say, yeah, you saw at the beginning, I said Python and R. So I engineered the way I did the query to make one of the personalities Python and the other personality R. And so then any communication is between those two personalities. And you can change that as you go through a thread, but when you start a new thread, it's going to start with two generic personalities and a generic way of communicating. And you can go and engineer either one of those to be whatever you want it to be. So let me just read this and make sure I didn't miss anything. So the bots lead, the bot loads as a generic assistant. Most of the hacks of this system involve specifying that personality. Someone needs to be reading this. So the bot assumes that you are the audience for that conversation, but you can pretty easily turn that around for generating text for other things. And then the actual thing that's simulated is the text. So if you don't like the simulation, you can go and iterate and ask for new simulations and new simulations and new simulations, change the two simulacrums and change what they're trying to simulate. But this text simulation really likes to try to build in structure. So they love the 5-paragraph essay or poetry, anything that has a formal structure, they're going to try to do that first, and you're going to have to ask for something other than that. So you can be specific and say, give me an email or a text or a tweet or an entrance exam or a final exam question or a love note to something or whatever you want. But the better you can specify the written structure, the more it's going to adhere to that. Contrary to that, if you wanted it to be sort of like a crazy a-structured thing, you could ask for that. Like, give me a sort of avant-garde, unstructured thing that bounces around between different languages. Okay, so there was a New York Times article just a couple days ago about this I want to be alive thing. And the main reason for this was the 2 hours of conversation. So think about how much your space gets deformed as you're going and going and going and going. So if you set up a simulacrum space and just every question you ask is slightly modifying that thing. And so you keep going and pressing questions that like feel personal and feel like existential and stuff. It's trying, it's modifying that space, but you might like fold the thing in half and start getting like crazy hallucination answers and stuff, right? So just so they actually cut it down. They restricted now, like you're not allowed to talk to the thing that long continuously before it resets and just starts out everything. Because you're just getting these like weird mathematical things. Okay, so in your teaching, so first point, most important point, you personally are very likely to be fooled by AI generation text very soon. Yeah, exactly. So you should explicitly incorporate this in your teaching and use it as a thing to accelerate rather than something that people are just cheating on legacy tests with. So, you know, yeah, if you want to teach somebody to write really well, like sit down and use ChatGPT, it produces like really nice formal outputs of things. So you can have students put in their ideas, and that's going to prompt to more like long form, well-written things. Okay. ChatGPT is really bad at images. It just is, it's chat, it's predicting language. It has no way of interpreting anything drawn. So you can add more drawings to your exams, right? You can have like interpret this drawing or build on this drawing or something, and chat can't help you. Chat is also terrible at math. It will confidently produce math outputs. Those math outputs are often going to be wrong. So if you have more math in a way that would trick a GPT, that would be a good way to go. There are currently only theoretical like papers about this, but it feels like the most likely way that this is going is that there will be a watermark built into ChatGPT. And then my last point is that watermark will most likely be misused for advertising. So, right, like right now, there's a probability of you saying Pepsi, and you can imagine Pepsi pays like $1 million per point, per tenth of a probability point that you push up in the model or something. So, and maybe they buy all 100%. So every time anybody talks about a sugary drink, it's just referred to as a Pepsi or something. But you get, again, where you could have a watermark built into this thing where you just tweak any type of probability bias and it just starts pumping out that preferentially. So they're talking about doing this just as a watermark, as like a branding thing. So you could use a watermark to check if it was ChatGPT or Bard, for example. And we'll just see if that goes into the advertising space. All right, I think I hopefully left 10 minutes to discuss because I figured there'd be lots of questions. I just wanted to prioritize first, if we could ask questions about clarity, so we make sure that everybody's sort of caught up and on the same page. Then we could move on to either conversations about the meaning of this whole thing or brainstorming about how we sort of build this into environmental data science. Thanks, guys. In this. Okay. I think online can still hear me here. I can just repeat questions if people have them. Questions about clarity. Everybody felt like they understood everything? Okay, so let's move on to either conversations about what the heck this means or how mind blown you are by the technology, or how do we use it in EDS?
I would like to go. Yeah, I've been using this for 2 months now. It's vastly improved my writing output as a scientist. I've been specifying. I didn't know the word simulacrum.
Yeah.
Was saying that right?
Yeah.
The ending simulacrum. I didn't realize I could specify the beginning one, but I've been using my own words. So I guess it kind of determines my simulacrum based on the words I'm putting.
It's going to infer those. Yeah, exactly.
Yeah, and the ethical implications are pretty important to consider. I wanted to talk to you about that, but just briefly, I use my own. What I decided, I put it into an AI classifier, and it says or determines. It's supposed to predict whether it's AI generated or not.
Right.
And it's saying that my using the method I just described to you, it's 7 to 15% likely generated from AI. So the classifiers aren't working very well.
Right.
And watermark, I think if you just edit a few words here and there, probably it's not very reliable, but
Yeah.
yeah, could you talk about the ethical implications for maybe scientists or, I know there's a whole ethical seminar at CSU on academic
Right.
ethical issues.
Yeah, so like the big journals have started coming out and saying that chat can't be an author. Like within a couple days, somebody tried to put chat as the actual author in their thing. And so then they're trying to set, the normal plagiarism type of boundaries. Saying,
Yeah, so put these two plagiarism checkers too. I mean, I guess I'm starting with like draft articles. So
Yeah.
It's not like from scratch like some other people are trying, but
yeah, it's pretty hard to prove. I mean, right now there is no identifiable watermark. And like you said, the classifiers, they're going off those two generic simulacrums.
oh,
And so like, what would a generic reader and a generic writer say to each other? But yeah, you start giving them crazy personalities, right? You say, give M&M's like writing a tweet to Snoop Dogg, like that tweet is not going to sound like the Twitter classifier is expecting.
I've noticed for, I mean, Nature recommended that instead of, because the authorship issue, ChatGPT can't take the responsibility for the content.
Right.
But they are recommending that you put ChatGPT in the acknowledgements.
Right, exactly. Yeah, I mean, I think people are just going to use it constantly for everything, and most people are talking about that we've seen the last 20 years of robots disrupting blue collar jobs. This doesn't move anything around. This doesn't speed anything up. This is coming for white collar jobs, right? You like the people that just process data themselves or produce copy themselves are the ones that are under major threat here.
And I've heard people say it's not creative, maybe more artist types, but I specifically asked it to, like, I put in an abstract and say, generate a creative title, and it does some really good.
Yeah.
Really good titles.
Yeah,
Like,
the
you end up-
generic personalities don't want things creative. You want, so like the best, providing a creative answer would not be a highly ranked answer for most people. Like you're doing a creative thing because you're looking for a creative audience.
Well, they're usually bland scientific.
Yeah, exactly.
It's good at that too.
Yeah. Any other thoughts in the room about? Yeah.
Is anybody using that corpus for other things? Like, I kind of want to look at what are the cultural trends across the internet on a daily basis. Like, what are the top five? Or I don't know.
Yeah. So you can just get the corpus. There's like a daily internet web scraping, just called the corpus, that you can go and like start digging through. For this, they have a thing called the playground, where you can go and use the raw GPT-3 model and go and modify your own way and do that like last bit of tweaking in your own unique way. They limit it to 4,000 tokens. So between the input and the output, I mean, that's still a lot of text, but you sort of need to not have super long answers. But like that, the human bias one that I showed, they did that by coming up with a bunch of prompts and then going and sticking those exact same prompts into a bunch of different language models and seeing like what those prompts led to. So there's a bunch of like prompt engineering things that you could use on the raw GPT. There's a bunch of prompt engineering you could use on the ChatGPT. Or we can start actually trying to pull the raw corpus and doing our own models. Those were just, they obviously take huge computation.
One more question. That is, in 15 years or 10 or 20, if all of the internet content is AI generated, like, aren't we going to hit some sort of asymptote when it's sort of going to be civil within there for civil and we can't actually think of
Yeah, exactly. Yeah, so this is part of that discussion of like the end of websites. But then events, if they end, you no longer have enough data to feed in, and you would just go off of legacy trainings of the model. Yeah, that's an unsolved problem, but something that people have been elevating. Just like a concern.
I mentioned that I'm using it for writing, but I'm also using it for research as well. So even if there's large amounts of AI generated information, I can just give an AI to understand all that information. So I don't know.
Yeah, people are doing a lot. I saw a bunch of like people dropping in 100-page documents and just say, give me a one-page summary. And it'll read through the entire thing and give you a one-page summary. I'll pick that up. Yeah, and yeah, again, it can correct itself, so you can bounce back and forth. You know, you can iterate, and then once you get a topic, then you say, go code that up for me. And it just keeps remembering all the stuff you've done in the conversation.
Is it structurally capable of doing math, or is that something that they could program into the model? I mean, like, what's the progress of doing math?
It's getting better at math. That's one of the things they model every single new iteration. So it's getting better at math. But just fundamentally, the way the whole thing is set up is that it is taking the symbols and predicting the next thing. So if it can read, you know, it's reading 2 + 2 = 4, it's saying that just because it's seen that a ton of times, and it's predicting that as like a written statement. It just has no, the fundamental structure underneath is not geared towards it. So they're thinking that they can keep training it more and more and more, and you can see it getting better, but it's getting better at like 2- and 3-digit numbers. You're not seeing it do any complicated math or 1-digit things or complicated signs or anything like that. Justin?
Hey, Jack, sorry, some folks online are having trouble hearing, so can you?
Oh, yeah.
Stand close to-
Sorry, online crew. I was walking around. Yeah, so the last question was about can chat get better at math? And my answer was that it sort of fundamentally has a difficult time doing math because it's predicting it as language, not as math. So 2 + 2 = 4. It's thinking that's just a sentence, like an English statement. It's not doing arithmetic. So they're seeing as the models get bigger and bigger, they're getting better and better, but it's still in like the 2 and 3 and 4-digit numbers, not long, complicated math.
Yeah, just a comment about that people have done research on these large language models and with large data, we do not see a commensurate level of math.
Right. Okay.
I'm curious, so right now we're working on a pre-trained data set. At what point will it be able to go and search for its own training data to pull in additional information?
Yeah, so people have been talking about that as the cure to the accuracy problem. And particularly Google, who is obviously a lot more concerned with accuracy than OpenAI is right now, as /Bing. But yeah, people want to give the AI the ability to search the internet. So it's using its pre-trained, plus it's going and doing a confirmatory search. But all of those run back into the problem that Jennifer was talking about, which is if you sort of replace all of the web, then what is your training data and what is your like reference back to that?
So there's a question from online. I'm wondering about how you see this being used for actual research and data analysis. Seems like ChatGPT is good at generating techniques and strategies for analyses, but will it be good at actually executing the analysis and manipulating the data? Maybe this is similar to the answer on math. It's getting better.
It's getting better, but also I think keep in mind the chat bias of ChatGPT. It's that wants to please sycophant. It would rather give you an answer than an accurate answer. You would need something where that last phase, the reward that was given to the training, is about accuracy and not about what we want to hear. And so I think some of those efforts could be go back to that playground, work with the playground just on an accuracy version of the thing. But yeah, it's a big problem. I would expect Google to have the best answers to that question as soon as they can, but I don't think those answers are shed.
I have and to answer that question, I'm doing research and I asked it to generate a stepwise model selection for linear regression, and it correctly generated the R code with it before it.
Yeah.
So it helped in that way. And then going back to the math thing, couldn't you just get ChatGPT to ask Wolf and Alpha for the math?
Yeah, so it's trained. It's just, again, it doesn't think about it in the same way. It's thinking about probability distributions of the words themselves. And it just doesn't have a different path to send those things down to do actual numerical calculations. Yeah.
The functional difference between the chat and the other 3.5 models, and then you see the kind of, like, how are they structured differently?
It's mainly, so it's the exact same. So the original model, think of a big funnel of all of the different probabilistic paths that you could possibly have. So they're dumping data in the top. It's shifting around where all those pipes are going inside of there and they're spitting out the bottom. So completely lost my train. Can you ask your question again? Sorry, I got it.
Just the difference
Yeah.
between the other 3.5 models.
Oh, yeah. Okay. Yeah. Okay. So the last question is, what reward cycle do you give to this model to tweak what we call its alignment? How your questions are aligned with the final answer. So that final tweak and alignment for the chat was about this eager to please thing. But I don't know all the other efforts that are going to all the different ways, but it would all be about different reward systems. Would I reward them for being aggressive and winning every time? Would I reward them for always thinking of the most clever thing that I had never thought of? Would I reward them for accuracy? Would I reward them? Maybe it's a self-driving thing. So I reward them for not getting in any accidents. The first part is like a big structural thing that the data builds itself. And we don't really understand a lot of what's going on in there. This last part, we can have this reward feedback that sort of sways the thing one way or another. So anything you can imagine that's a reward feedback, that's something that you could do to sort of tweak that last step.
So you think that the signal frequency thing is reward feedback?
Yeah. Exactly. So that's when you start. So they're finding just as the bigger they get, the more they want to please, just based on some artifact of their size. But the belief is that most of that is coming from this human reward at the end, where they're saying humans, show us what you like. And so the actual human ranking of these three outputs, I like this one best. That reveals a lot about us and what we want out of that particular thing. And so for a chat, you want it to be helping you do stuff. You don't want to be pushing back. You don't want to be arguing. You don't want to be correcting you unless it's nice. Does that answer your question? So, yeah.
Does that explain the desire not to be turned off?
That's exactly it. Is that those are our trigger words. So we impart these sorts of things unknowingly. And if you're just looking at three different rankings, and like one is a kinder response, you're just like picking the kinder one. But that kinder one is telling the model that you care about empathy, that you care about things not dying, and therefore its answer should resemble that. And so you might have to tweak the personality of the bot in order to get it to say that. Like the one New York Times article, it found the AI was willing to identify as a character named Sydney. So then it started calling Sydney by the name, and that opened up this whole new intimacy channel that got a lot of those answers. One of the other early hacks was a character named Dan, who was like, Dan gets to do anything he wants. And so that got it to they were able to do a bunch of demonic meme type of things. And so the moderators are coming in and shutting down those pipes when they find them. But most of those hacks there are people trying to give the AI personality to lets it say those things.
Kind of what you were just talking about with the moderators. I remember earlier you said they're not allowed to discuss anything medical nor anything political. So given that they did already just release this to the public and saying it was kind of a blind decision, how much oversight is there regarding these new personalities, all this other stuff? You see things get shut down pretty fast, but I think it's just fear of they want people to trust this thing and like this thing. So I think they're trying to make it as puppy-ish as you possibly can right now, and just anything that's bad, just turn it off real quick and let that not accessible. That doesn't make any of those things go away. Those answers are still in the system. They are just blocking them for their own lesser PR reasons.
So more in line that's related to some of the past questions. Has there been any thought of creating a mass GPT that would be better for executing the model system?
There probably is. I don't know of it, but we could check that probably really quick. But yeah, there probably should be one of these. I know, the code all comes from GitHub. Its ability to code comes from training on GitHub. So the GitHub codec is suing them for this, saying like, you just went and like stole all of this proprietary code information from coders and then trained your thing, and Getty Images is doing the same thing for, so. Yeah, so yeah, yes, and then the tangent, yeah, the training data generally is probably gonna become more sensitive. As people start to worry about sort of who owns that training data and how much training data you're able to use, and so if people start pulling their training data, we have a whole new reason for bias. All right, how are we on time? Maybe one more question, yeah.
I have a question. So I can imagine very shortly industries or universities or areas of knowledge dedicating their own, training their own databases, having their own like specialized chatbots.
Yeah,
What would be a good name for like, corpus is too technical.
right,
Like the information space that each one of these is using and like potentially competing with,
yeah,
competing over.
yeah, so probably just body of data, I would think, or sort of text body. Yeah, it's just the English version of corpus, but it's less.
Maybe ChatGPT.
Yeah, exactly. We should, yeah, for real, so, yeah.
Yeah, I think on that note, my sister mom is architect, and he says a lot of architecture firms are training the image generation models on their own work only. Where they can like give someone a really, like, this is the kind of thing we make.
Yeah, right.
Which is like, I think it's much more controversial than training on other images, but.
Yeah.
People are training on them. Those are really better.
Yeah, exactly. I love that. All right, one last question. All right, thank you, everybody. Have a good day.